Okay, apparently this is having a hissy fit. I need it to like close and reopen it. 29, 29. And did everybody get a pink sheet? Everyone got a pink one? We're going to be starting to use that today. Basically what's going to happen is today we're going to learn about polyatomic ions. You may or may not get to that quiz today. Either way is fine. On the board, I have listed the people who have not taken quizzes 1, 2, or 3. Definitely you want to be like, unless you've been away for a while and are like, have got 3 of them, you'll want to be finishing quiz 3 today and hopefully quiz 4, okay? That would be the goal, would be to at least finish quiz 4 today if at all possible, okay? Restart the program. Yes, that's what I would like to do. Thank you very much. Okay. Okay, so we're just waiting for this thing to get itself started here. Okay. Hello. Come along. Okay, why do I have 2 of this open? Let's get rid of this one. There we go. 7, block 7, that's what we want. Okay. So this first 4.2a, which is the one that starts on page, what page are we on? 29, the one that starts on page 29. This first page is not really about how to name things per se, although there's some of that in there. A lot of it is just about what polyatomic ions are and how they work. Sorry, I'm just trying to find a new battery for my, are those batteries? No. Come on. Surely I have another battery. Do I not? Okay, we'll take that one. So, what does the prefix poly mean? Many. So if we have poly, which means many, and we have atomic, which means atoms, these are atoms that are made of many, these are ions that are made of many atoms, okay? Monatomic ions have a charge because they've either lost or gained electrons. Polyatomic ions also have a charge because they have lost or gained electrons. However, in a polyatomic ion, we have 2 or more atoms bonded together. In this particular example, we have nitrogen. What kind of an element is nitrogen? It is a non-metal. And we also have 3 oxygen atoms. What kind of element is oxygen? Also a non-metal. If we have a non-metal plus a non-metal, what kind of bonding do we get? Covalent bonding. So in between the nitrogen and the oxygen, each of them, we have covalent bonds. Okay? However, together, these things carry a charge. Okay? Somewhere or other, they got an extra electron. Maybe it's from a sodium that was looking to get rid of its electron. Okay? Together, they carry a charge. We're on page 29. So we would actually write the formula for this. Can anyone guess how we would write the formula? We have an N, an O3, and because it has a -1 charge, we would write minus. This particular polyatomic ion is called nitrate. You will notice if you look at your pink sheet that a lot of the polyatomic ions have the ending 8. So take a look at your So 8 is definitely a polyatomic ending. Ite is another one, okay? And just like any other atom, or sorry, any other ion, polyatomic ions get their charge because they have lost or gained an electron. So let us consider a different polyatomic ion, the ammonium ion, which is NH4+, which means we have one nitrogen. How many valence electrons does nitrogen have? It has 5. 1, 2, 3, 4, 5. How many hydrogens are in the ammonium ion? 4 of them. So we're going to have hydrogen, 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 hydrogen. And each hydrogen has only one electron, yes? In total, how many electrons does that give us? If we have one nitrogen with 5 electrons and each hydrogen, 4 of them have 1 electron each. That's 9 electrons in total. So that's how many nitrogen and 4 hydrogens have. If you look at the dot and cross structure for ammonium, NH4+, count up the number of electrons in this structure. How many electrons? There are 8 electrons. So somewhere or other, one of the electrons has gone missing. It's gone somewhere else. Perhaps it's gone to a chlorine atom that needs an electron to fill its shell. Okay? And that's why we have a plus charge there. Do you need to be able to show that? No, you do not. Okay? But that's, you know, sometimes people are like, well, where did that charge come from? Where did it go? It's because, you know, it just either gained or lost electrons just like anything else. Now, here we have a combination of magnesium, which is in column 2, so it has a 2+ charge, and this nitrate ion, which is NO3, which has a -1 charge. What do you remember about compounds? What about the charge of compounds? Compounds are always neutral, yes. If they are always neutral, and I have magnesium, which has 2+, and I have nitrate, which has a negative, which essentially means -1, how could I make a compound containing those 2 ions neutral? Tell your partner, how could we make that compound neutral? Magnesium is 2+, NO3 is -1. Tell your partner, how can we make that compound neutral? does it make sense that we would have to have a second nitrate ion, which would give us, if we added up all our negative charges, that would give us -2. And if we added up all our positive charges, that would give us +2. And those two are now equal and opposite. Yes, which would give us a neutral particle. Okay. So the space filling model would look like this, but if we want to write the formula, one thing that we have to do is, if I want to have 2 groups of NO3, I have to put brackets around that entire group to say I want 2 of this entire thing. It is very much like in math class. Let's say you had x plus y, and you wanted to multiply that entire thing by 2. What would you do? You would put brackets and you would multiply it by 2, yes? So if you have a polyatomic ion and you want to have 2 of them, you have to put brackets around it and then a 2 on the outside, okay? What would we name this compound? What would the first name of the compound be? Magnesium. Does magnesium need a Roman numeral? How do you know if it needs a Roman numeral or not? Yeah, you go and you look and you say, is magnesium in the red zone? And the answer is no, it's not in the red zone. And so does it need a Roman numeral? No. Okay, so going back here, magnesium is not in the red zone. Therefore, no Roman numeral. And then when you have a polyatomic ion, you are going to go, unless you know you memorize these, and that seems like a lot of trouble, you're going to go to your pink sheet. And you're going to look probably under N. Okay, they are in alphabetical order by name. So we're going to go to our data sheets and look up NO3. Okay, and when we look up NO3, we go, oh, there it is. Its name is nitrate. Okay, you'll see a lot of 8s, you'll see a lot of ites. That's different than the elements on the periodic table whose names change to ide. Yes? Okay, most polyatomic atoms or elements are 8s and ites. So we just go back. And its name then is magnesium nitrate. It's actually really easy to name polyatomic ions because you just look them up and then write their name down. You don't have to do anything fancy. Why is this pen causing me so much grief? There we go. Okay. All right. We're not going to meet all the polyatomic ions today. We're just going to meet a few. Like I said, we will revisit this worksheet, but we will look at ammonium. Ammonium is special because it is one of only 2 polyatomic cations. And what is the charge of a cation? A cation is a what kind of ion? Positive ion. I would like you to look on your pink sheet and tell me who is the only other positive polyatomic ion? Mercury. Okay. So if I go up here, woo, where'd it go? So you'll notice it says mercury, and it says mercury 1. What does that Roman numeral 1 tell us? Roman numeral 1 tells us have we forgotten? It tells us the charge. Okay, the Roman numerals tell us the charge of the Hg ion. So the Roman numeral tells the charge of the Hg ion. Yes. I was so hoping you would bring that up, because that's very astute. Look, he says, there's a 1 there, but what's up with this? I see a 2 plus here. I'd like you to chat amongst yourselves and see if you can think of a reason why, even though there is a 2 plus, it's got a Roman numeral of 1, which means the charge is 1. How is that possible? Anyone got any ideas they'd like to share? Yeah? Yeah, there are 2 Hgs, right? Not only does it have a 2 plus charge, but there are 2 Hgs. So what you really have is you have an Hg bonded to an Hg. Each of these will be 1 plus, which gives us a total of 2 plus. But the charge on each individual Hg is plus 1. And it's only because there are 2 of them that the charge is 2 plus. So watch out for that. Mercury is a weird little beastie. Yes, it's one of only 2 positive polyatomic ions. Okay, there's not a lot of them. Mercury is a liquid at room temperature, so it's just an odd duck. It just does its own thing. Okay, it's a weird little element. Who is our other positive polyatomic ion? Ammonium, okay? Ammonium is going to be important because you're going to need to recognize it as a part of an ionic compound. Normally, ionic compounds start with metals, but they can also start with ammonium, okay? So we're going to get good at looking for ammonium. We are on page 29, Jack. Okay. Or actually, are we on page, we're on page 30 now. My apologies. Whoop, there we go. Oh, I don't want block 6, I want block 7. Where are we? There we are. Okay. Out of all my blocks, I like both my grade 9 blocks. They're different. The other one's smaller, so it's a little bit easier to like get around to everyone and get everyone some help, right? Whereas this block, it's a lot more hectic because I have to go so many different more places, right? We've got 20 as opposed to 30. You're like, but I want to know, do you love me best, right? That's what you're asking. I love you all the same. All my students, I love you all the same. Just like if I had more than one child, but I only have one. I have one favorite son because I only have one son. Okay. So here is our, it's not our only polyatomic ion, because there's also Hg2, 2+. But I do want you to look at what we've got. We have a nonmetal, and we have a hydrogen is a nonmetal, and chloride is a non-metal. So many people would look at this and say, I've got nonmetal and nonmetal. What kind of compound must that be? It must be covalent, but it's not. The reason it's not covalent is that this entire group is a positive ion, and the chloride is the negative ion. So you need to watch out for NH4. If a compound begins with a metal, or if it begins with NH4, it is an ionic compound. Ionic compounds begin with either A, a metal, or B, NH4. So you have to watch out for that NH4 because it looks like a covalent compound, but it is not. Okay, NH4 is a polyatomic ion. And in fact, you can see this structure here. What kind of a structure is this entire thing here? That is a crystal lattice. And if you were to actually label them, we would have our chlorides, which have negative charges, right? So we have alternating negatives, and then the ammoniums are all positive. What's that? Oh, I forgot the E. A crystal lattic, kind of like an attic. What is the ratio of ammonium to chloride? How many to how many? 1/4? 1/4. Well, let's count them up. How many ammonium do we have? It's okay. We're going to count them anyway. 1, 2, 3, 4, 5, 6, 7, 8 ammonium. Yes? How many chlorides do we have? The green ones. 1, 2, 3, 4, 5, 6, 7, 8 chlorides. So if we simplify that ratio, because in ionic compounds we always have our simplest ratio, that's 1 NH4 for every 1 Cl minus. Yes? And I'd like you to notice something about this formula when we write it like this. How many NH4s are in that formula? How many ammoniums? There's just 1 NH4. And you'll notice, did we put brackets around it? Are there brackets around it? We don't use any brackets for one of them, okay? Sometimes this can lead to a little confusion because people will see the 4 and they will think that there are 4 ammoniums. Yes? But if you wanted to have 4 ammoniums, you would have to write NH4 and then a little 4. Because the NH4 is just the little group. It's a nitrogen attached to 4 hydrogens, and as a group, that thing has a positive charge. Is good? Okay. Here is ammonium oxide. What is the charge of an oxide ion? Group 16. Tell your partner, what is the charge of an oxide ion? It is 2 minus. Yes? What is the charge of the ammonium ion? If you forget, you can always go back to the data sheet and you can look and you can say, oh, it is +1. Okay? So back we go, we have NH4 plus. But remember, we need our compound to be neutral. How can we make it neutral if we have an oxygen and an ammonium? What do we need? We need another ammonium. Yes, because that's going to give us a +2 charge, which will balance out the -2 charge, okay, which gives us a neutral compound. And you can see the ratio. If you were to count them all, and I'd like you guys to appreciate, I actually hand cut and pasted each one of these things onto there so that we had like a lovely little ratio. There are actually 72 NH4s and 36 O's. And if you simplify that, that is a 2-to-1 ratio. And how do you show that you have 2? Anytime you do that, you have to put brackets around it when you have more than one of that polyatomic ion. So in order to show that you have 2 of them, you have to have it around that whole thing. Okay. And we just name it ammonium. And then oxide, you still have to change the ending. If it's an element, you still need to change the ending of the second word to "ide." Okay? Oxide. One last one, and then we're going to move on to the practicalities of naming. Okay? The next one is acetate. And it looks really funny, okay, because it's got a C and then an H3 and then a C, and then we write 2 O's separately. So we write CH3COO, which seems really complicated because we could, if we wanted to, actually write it like this: C2H3O2. That's the same thing with a negative charge. But look at the structure. You see how we have a carbon here, and it's bonded to 1, 2, 3 hydrogens, yes? On the right-hand side, we have a second carbon that is bonded to an O and bonded to another O. And that's actually really going to be important if you go into any sort of biology or organic chemistry, because that C, it's got a double bond O and then it has a single bond O, and you can have a hydrogen on the end of that, and that actually then acts as an acid. Okay, so that's going to be one of the groups if you take like grade 11 chemistry or grade 12 biology that you'll notice. Okay, so that's why we write it in such a funny fashion, because it actually shows the structure a little bit better. You don't need to know any of that. You just need to know that that's, you know, if you're like, why is this written so funny? That's why. You will see it like this as well, but probably not in my class. I think it's too confusing to have 2 different symbols for the same ion. Okay? What is the charge of a sodium ion? Sodium is in group 1. +1. Acetate is CH3, COO with a -1. Do we need to do anything in order to balance out the charges? Or are we already good? We're already good, so we just need one sodium so we don't have any subscript and one CH3COO. And even though that formula looks big and horrible and awful, it's really just two things. There's a cation, the positive ion, and then there's the anion. You'll never ever have like cation, cation, anion. You won't have to name three things. You won't have cation, anion, anion, anion. Okay, there's always going to be one cation and one anion. And when it comes to naming, you're only going to give two names. You'll name the cation, you'll name the anion, and then you're done. Here are some other acetate compounds. Calcium acetate. Calcium is 2+, so we need 2 of the -1s to balance that out. That gives us a 2+ and a 2-. Sometimes you'll see people write this formula like this. Is that okay? No, it's not okay, because that would be like saying, I want to multiply x plus y times 2, and so I put a 2 here. Yeah? That's not x plus y times 2. That's 2x plus y. Yes? In order to have x plus y times 2, you need those brackets. And it's exactly the same here. What this would do is it would only refer to that one oxygen and not to the rest of the atom, or the rest of the ion rather. Okay? So you do have to have the bracket, so then it refers to everything inside the bracket. Everybody gets doubled. Okay? Iron 3. What does this 3 tell us? That tells us the charge, and that means that we're going to have an iron with a 3+ charge, which means we need 3 of the negative acetate. So we're going to have brackets and a 3. Why is there no Roman numeral? Take a look on your yellow periodic table. There's silver right there. And what do you notice? It is not in the red zone, therefore it does not use a Roman numeral. Okay, so there's no Roman numeral because it is not in the red zone. Iron, of course, is in the red zone. Okay, we're going to leave this one for today. We will come back to it so we can become more familiar with polyatomic ions, but it's going to get really boring if we keep doing that. So we are actually going to turn to page 39. Page 39. So an ionic compound, we know, hopefully we know, it's made of a cation and an anion. The cation is either going to be a metal or it's going to be NH4. So you know that your cation is the metal. Once you hit the end of the metal in the formula, you're at the end of the cation. Everything else will be the anion. Because there's only ever going to be two things to name, the cation and the anion. Two things to name. So the only real difficulty here is just figuring out where the cation finishes and knowing that everything after the cation is the anion. So you're either going to have, where does the cation end? It either ends after the metal ion or it ends after NH4. So the cation is almost always one element long unless you have NH4, in which case it's 2 elements long. Everything after that is always the anion. Okay, so only 2 things to name. Let's take a look at this one here. AlPO4. Al is a metal. So that's your cation. That means that the PO4, everything else is the anion. Could you please go on your pink sheet and look up PO4? Probably in the P section. Yes. Now the nice thing about this sheet is that it is in alphabetical order, so you will find phosphate in the P's. We go down here, there's phosphate. It is PO4, 3-. Okay, and mostly you'll be able to find things like things with P in them will be in the P's, things with chlorine in them will be in the Cl's. Okay, we've got chlorate, chlorate. However, you might need to dig a little harder sometimes because they are alphabetical by name. Look what happens over here. We have a chlorine, which is in the name, chlor, but it's over in the H's because that name is actually hypochlorite. So if you don't find an ion where you think you would, you might have to look a little further. Does that make sense? So maybe you're looking for something that has phosphorus in it and you're like, oh heck, I didn't find it there, but oh look, I've got phosphorus here. So yeah, you might have to dig a little further. So just keep looking if you're not finding it initially, okay? So that would be aluminum phosphate, and you don't have to do anything else to the name because aluminum does not need a Roman numeral, okay? Remember, watch out for NH4. NH4 is the cation. What is the name of that cation, NH4? That is ammonium. And then all we're left with is the O. What do we name O? Ox what? Ide, okay? When you have an element that second word changes to "ide." Just like before. Okay, nothing new there. Sometimes you get a bunch of capital letters in a row and it looks a little ugly. Okay, and you're like, oh my God, there's so many capital letters. There's like K, N, O, and I don't get a number till the very end. But remember, unless you have NH4, it's going to be a single element. So you're just going to say, that's my first capital letter, that is my first element. So that is my cation, and everything else is going to be the anion. Okay, so the NO2 is the anion. Go look up NO2 on your pink sheet. Earlier on, we had NO3, and that was nitrate. Now we have NO2, which is nitrite. If you're into seeing if you like seeing patterns in things, the one that has more oxygens is going to be the 8, and the one that has less oxygens is going to be the ite. You'll see the same pattern in phosphate, which has 4, and phosphite, which has 3 oxygens. You'll see it in sulfate, which has 4 oxygens, and sulfite, which has 3 oxygens. And again, if you're interested in seeing patterns, you'll notice that they always have the same charge, regardless of how many oxygens there are. Sulfate is always, the sulfur ones are always 2 minus, the phosphorus ones are always 3 minus, and the chlorine ones, of which there's a whole ton, are always -1. There's perchlorate, there's hypochlorite, which is -1, and there's chlorate and chlorite. Okay, so that's if you're interested in patterns. You're not required to know anything about that, but it is interesting, and it does help you remember them if that's something that's important to you. Okay. Oh my God, are we back at the beginning again? Do I have to scroll through this whole flipping thing? Oh no, come back, come back, come back. Oh. Okay, there we go. Okay, come on, come on, come on, come on. Sorry, I'm having a moment. Okay, there we go. Okay, some of the rest of them are easy. You can go, okay, I've got my cation, which is Mg. Everything else is my anion. So that would be named magnesium chlorate. And just because I want you to really remember to watch for NH4, even though this looks like, oh, it's all nonmetals, if you see NH4, you know that that is a cation, which means the compound is ionic. It's not covalent. And if it's not covalent, you do not use what do ionic compounds never use in their names? Prefixes. So even though it's all nonmetals, because ammonium is a cation that is ionic, and ionic compounds never use prefixes. And here again, we have ammonium and we have nitrate. So what I'm going to get you to do is you are going to do page 40. And on this page, you do not need to name it. Do not name on this page. You are just going to say, who is my cation? Na is the cation, and the rest of it, all the rest of it is the anion. So I'm going to get you to do that. The answers are in your answer key. If you don't have an answer key, let me know. I will bring you one. And then once you have finished that, you can also do pages 41 and 42. So your priorities today are, if you haven't done quiz 3, you're going to finish pages 13 and 14 and do quiz 3. If you haven't done quiz 4, you're going to make sure you've practiced on 19, 20, 21 and do quiz 4. And if you're all caught up all the way to quiz 4, which some people are, you can work on this stuff and then do quiz 5. So if you see your name on the board, that means that you were probably away at some point and got a little bit behind on some of the quizzes. And so your job would be first to start with quiz 1 and then quiz 2 and then work your way to quiz 3. Okay? I'll be right with you. I'm just going to turn on the lights. I will be back in about 1 minute. I'm just heading downstairs for a moment. Help yourself to the quiz you need one. And I put my book for recording marks. Oh, right here under my computer keyboard. Thank you. Gabia. Sure, yeah. I think you've already done quiz 3.
No.
Oh, no, you haven't. No, you haven't. Never mind.
Yeah.
Oh, shit.
You know how to get it? Good. Okay. Ida.
Number 2 and 3?
Yay. Evan.
Do I get the same one or just?
You'll take 3B. Yeah. Hi. You can go look them up on here. Ish.
There's like 4.
Yeah, that's okay.
They're all the same.
Yeah, because this one's going to be bicarbonate. This one's binoxalate. Yes? You need prefixes when the compound is covalent. Are any of these covalent?
No.
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 Bingo. Kaylin. Yay. So folks, I'm going to give you back your test as well, so you can take a look at it. If there is a star on your test, it means if you want to come in and do corrections, then you can just make arrangements to come and see me. If there's no star, you did well enough that you don't need to do corrections, you'll be fine, okay? Of course, if you want to come over and, and go over it with me, you can. Nothing wrong with that. Oh my God. Angelo. So when you're done, you can pop them in the tray here. Let me know if you have any questions. Thank you. Yes, please. Thank you. Three.
I probably would have known those.
Yeah, it was just like
Oh, I thought. Oh.
this is the one where you have
Yeah, I think that's what.
Maybe. But
I
anyway,
think if it's like 3 passages, one has something.
I don't think so. This was your only quiz 3. Yeah. Oh yeah. Yep.
Oh, okay.
You can do it on Monday. Okay. So yeah. So you'll be looking at like quiz 3, 4, and hopefully 5 on Monday. Okay.
When I did this on the test, I had no idea what I was doing. So I
Okay.
just kind of faked it till I made
Yeah.
it.
Yeah. Yeah. I get it.
What was what did I do wrong?
So this guy has 3 that it needs to get rid of. So you would simply need another fluorine and another fluorine.
Because I kept like redoing it. I thought
And you're
there
like,
was
it's
something.
not working.
And I just at one
It's
point I
not
was like, maybe
working.
I'm overthinking this, so I just left
Yeah.
it. But I knew something was wrong.
Yeah. Yeah. So you just needed 2 more fluorines, and then they could each accept 1, and then you
this
would have.
have been F3. Okay, that would
Yeah. Exactly. Exactly. Hello.
Wait, do we learn the more?
Monotonic just means those are all the ones we've been dealing with till now, like O2 minus, right? So like all of these are monotonic. Yeah.
Okay.
Yeah.
Um,
Excellent. Some of the second page, yeah, and some of that. Oh my God. So yeah, you might be able to school. Okay. Do you need me to come grab you, or are you gonna remember?
for this part, I just need to add brackets, right?
Yes, and they're not shared, so they would actually be separate from one another because it's aluminum is a metal, and so that you would actually have like the aluminum would be like Al 3 plus, and then you would have fluoride.
Yeah, I didn't.
Right, and then it would be minus. Yeah. Anyway, yeah. You mostly got it, so that's pretty good actually. You managed to get a 3-to-1 ratio, which not lots of people did. So yeah. That will be quiz number. Let's see, that's 4.1C. So that would be quiz number 3. Yes. Yeah.
Some of it, but I'll do the rest.
Do the rest. Yeah, sounds good. Thank you. Thank you. If it's the second version, I have to think a little bit more.
We have to return our test.
Yes, please. That'd be great. Just inside is great. Yeah. Perfect. Thank you. Jude. Nice. Thank you, sir. Thank you. Let's mark that for you right now. So just don't change the ending of the first word, which you didn't for any of the others, but you did for that one. Okie doke.
Thanks.
Alrighty, thanks. Thank you. Yay, thank you.
This back as well.
Yes, please. Thank you. Yes. Oh, okay, thank you. Thank you, thank you. Bye. Hello. I know, right? Yeah, yeah, yeah. Totally fine to just stay here and work. I know, that was last year though. Because I heard the whole story because my son was in university at the time when it happened. Huh? Yep. Oh, I think I saw it on a web page somewhere. Not like official news. Oh yeah. Well, that makes sense.
It was so shocking. I'm like spreading that information to many people here.
Mm-hmm.
Everybody talks so they get worried.
Okay.
she comes back, he gets one of those photographs. Thank you.
Students with an elevator pass, please return it to the office before you leave. Thank you.
Starting out. I didn't want both of them. I just wanted one of them. I didn't want both of them. I just wanted one of them. I don't know. No. Don't know. 50. I wanted one for my mom, but I did not want two. Thank you. Bye.
AP is done. You should be able to leave faster, not slower.